Alright, this is 4F notes. Let's start off by first graphing each of the following. So let's graph y equals 3x squared plus 4. So this means this is moved up 4, so it has a vertex of 0, 4. And we have a factor of 3. So 0, 1, 2, 0, 1, 4 times 3. So it becomes 3, 12. So let's go right 1 up 3 and left 1 up 3 are reflected. Alright, my next point won't fit. So here's my parabola. Alright, list the zeros. Notice that this is not touching the x-axis, so there's no zeros. In order to have a solution or a zero, it has to touch the x-axis, which this graph doesn't. Alright, let's look at the next one. My vertex is negative 1, negative 4. So negative 1, negative 4. This time my a is negative 2. So I'm going to multiply by negative 2. So I get negative 2, negative 8. So for my vertex, I'm going to go right 1 down 2 and reflect it. And over 2 down 8 won't fit. Alright, so here's my graph for this one. Alright, here again, so it says list the x-intercepts. Here again, it's not touching the x-axis, so there's none. So in order for a quadratic to have a real solution, it must touch the x-axis. Alright, a quadratic equation has real solution if it intersects the x-axis. Not all quadratic equations have real number solutions. For example, x squared equals negative 4 has no real number solution because the square of any real number will never equal a negative number. So we're going to look at complex solutions today, solutions with imaginary parts. So here's an example of, or the example that we just graphed. Let's solve it now. Because there's only one x squared term, we can isolate our x squared term. So we're going to get 3x squared equals negative 4. Divide by 3. Square root both sides. Now here again we have two solutions. We've still got to remember to have our plus or minus. So we're going to have the square root of negative 4 over the square root of 3. Alright, let's simplify this. Well, from our unit 1, we learned that the square root of negative 4 is 2i over the square root of 3. And we shouldn't leave a square root in the denominator, so we're going to rationalize. So we're going to multiply by the square root of 3 over the square root of 3. So our final answer is plus or minus 2 square root of 3 over 3i. So we're going to write it in standard form. Alright, so like I said, we're going to be dealing with today is going to have equations with complex solutions. Alright, let's look at the solution to that other graph that we did. Alright, here again we're going to isolate this x plus 1 squared term. We don't want to FOIL it out, we want to isolate it. So we're going to get negative 2 x plus 1 squared is equal to 4. Divide by negative 2. We're going to get negative 2. Square root both sides. So we're going to get plus or minus the square root of negative 2. Alright, move the 1. Alright, let's go ahead and clean up this square root of negative 2. We can pull the I out. So negative 1 plus or minus the square root of 2i on the outside. So your two solutions are negative 1 minus the square root of 2i or negative 1 plus the square root of 2i. Notice that these are conjugates. When you have complex solutions, you're always going to have to come in pairs. They're going to be conjugates of each other. Alright, you could put the I, you could also write it like this. I just write it in this previous form because that's standard form. Okay, so that's what we're going to be doing today, solving equations with non-real solutions. Let's look at one more where we can isolate. So notice here I just have a single x squared term, so I can combine like terms. Okay, so I'm going to subtract 11x squared. So 1 is equal to negative 9x squared. I'm going to divide by negative 9. Alright, I'm going to rewrite this. I'm going to pull the negative up into the numerator because it's going to save me a step. Alright, let's square root both sides. So we're going to get plus or minus the square root of -1 over the square root of 9. So my final answers are, that's going to be I over the square root of 9 is 3. So let's write it in standard form, plus or minus 1/3 I. So my two answers are -1/3 I and +1/3 I. Okay, now we're going to look at the quadratic formula. So from your Algebra 1 days, you should have seen the quadratic formula before. But if not, commit it to memory. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This b squared minus 4ac is called the discriminant. And we'll come back and look at that in a moment. Okay. Now, in order to be able to use the quadratic formula, our equation has to be in standard form. So let's look at the first one. Let's move the 7 and put this thing in standard form. Now, you use the quadratic formula when you can't isolate a square term or factor. So things that aren't able to be factored, you can use the quadratic formula. So we need the coefficients. Our a is 1, our b is -5, and our c is -7. And we're just going to plug and chug into that formula and solve for x. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now notice when I plug these in, I'm putting parentheses around those values as I plug them in. That's going to help me not drop a negative or mess up with my signs. Alright, now it's just got to clean it up. So we have 5 plus or minus the square root of 25 plus 28 all over 2. Alright, just simplifying. 5 plus or minus, add 25 and 28 together and you're going to get 53 all over 2. Alright, 53, the square root of 53. I'm looking for pairs. There's no pairs in 53. So I can leave this alone, put it in standard form, plus or minus the square root of 53 over 2. So my two answers are 5/2 minus the square root of 53 over 2, and 5/2 plus the square root of 53 over 2. Notice here again that these are conjugates of each other. These are irrational answers, because the square root of 53 doesn't have a perfect square. It's not a perfect, 53 is not a perfect square. So these are irrational numbers. Now notice that they're conjugates of each other. Irrational answers always come in pairs. Alright, we're just going to continue practicing with some of these. Just refamiliarize yourself with using the quadratic formula. Alright, here again we need to put this in standard form. So let's combine like terms. So we're going to get 16x squared minus 40x plus 25 equals 0. So here's my A, my B, and my C. Alright, let's plug in. X is equal to the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Alright, now we just get to clean up. So we get x is equal to 40 plus or minus the square root, 40 squared is 1600, or negative 40 squared is 1600, minus 4 times 16 times 25 is 1600 again, all over 32. Alright, so we're going to get 40, well, this is 0, so we're done with that, all over 32. So here's one example where you're going to have one answer. And if we were to graph this, we would see it only touches the x-axis at one spot. Alright, let's simplify this. So our final answer is 5/4. So this actually factored. This would factor, since our solution is 5/4, this would have factored to 4x minus 5 squared. Going backwards from a 0 to a factor. And when you graph it, like I said, it's only going to touch the x-axis is at 1 1/4. It's only going to touch it once. We'll look at this in class. Okay? It's considered to be a double root. It's called a double root. All right, let's look at one more example of this. All right, first of all, it's already in standard form. So let's do our A, our B, and our C. All right, plug into the quadratic formula. The opposite of B plus or minus the square root of B squared minus 4AC all over 2A. All right, cleanup time. So we get 6 plus or minus the square root of 36 minus 40 all over 2. So we have 6 plus or minus the square root of negative 4 over 2. So x is equal to 6 plus or minus the square root of negative 4 is 2I over 2. All right, let's clean it up. 6 halves plus or minus 2 over 2I. So our final answer is 3 plus or minus I. So my two answers are 3 minus I and 3 plus I. Here again, notice that these are conjugates. This is a complex answer. So that means this graph wouldn't touch the x-axis. They're a complex answer, and they're conjugates of each other. Irrational answers and imaginary answers or complex answers always are conjugates, always come in pairs. All right, let's look at our last topic for these notes. All right, using the discriminant. The discriminant, which is your b squared minus 4ac, can tell you how many and what type of solutions. So add the following to your notes. B squared minus 4ac, if it's positive, if it's greater than 0, there's going to be 2 real solutions. So your graph is going to touch the x-axis twice. If b squared minus 4ac is equal to 0, there's 1 real solution. And if b squared minus 4ac is less than 0 or negative, there's no real solution. Notice it's not touching the x-axis. So in a quadratic, we can have 2 real, 1 real, or 2 imaginary solutions. We can't ever have just one imaginary or one irrational. Okay, so let's see what you're going to be asked to do with this. It says find the discriminant and use it to determine if the solution has 1 real, 2 real, or 2 imaginary solutions. All right, first of all, it needs to be in standard form. I still need A, which is 1, B, which is 4, and C, which is 3. Now here I'm only finding the discriminant, which is this. All right, let's see what that is. So we got 4 squared plus 4 times A times C. All right, this is 4 plus 12, which is 16. 16 is greater than 0. We know we have 2 real solutions. Okay, moving on. Let's look at another one. All right, here again, this is already in standard form. So I now just need my A, my B, and my C. My discriminant. All right, let's plug in. Negative 2 squared minus 4 times 1 times 4. That's 4 minus 16, which is negative 12. Since negative 12 is less than 0, we know that there are 2 imaginary solutions. Or 0 and 0 real solutions. Okay. All right, one more. All right, here again, it's already in standard form. So we need our A is 9, B is negative 12, and C is 4. All right, the discriminant, B squared minus 4AC. So B squared minus 4AC. All right, negative 12 squared is 144. minus 36 times 4 is 144. So this is equal to 0. Well, 0 is equal to 0, so that means there's one real solution. And 0 imaginary. Okay. All right, if you have any questions, please ask during class.